Bismillah ar-Rahman ar-Rahim. This subject is called further gas and vapor analysis. It begins by the gas chromatography and mass spectrometry. Both of them are versatile techniques, which means that they are variable in their mechanism of action. We'll show it later on in a translation. It measures the concentration of anesthetic agents and other gases present in the mixture, commonly employed in laboratory mainly, not in the operative theater. Gas chromatography. Chromatography means write in color, literally. It's if we pour a mixture of dyes, as you can see from the figure, in a supportive media made of calcium carbonate, as you can see, the components of the mixture will be separated in bands, and after a while, these bands are being released in this final cup. So this pouring process is called the mobile phase, and the supportive media where the components of the mixture are being present as is called the stationary phase. So this is an example of the chromatography apparatus. The chromatography apparatus, as you can see from the drawing, it's made of a carrier gas. This carrier gas mainly is made of nitrogen or helium. This carrier gas, through a flow meter from the cylinder, as you can see, is being introduced into the system. And this port where the gas can be introduced, the mixture, or if it's liquid, it can be vaporized by heat and introduced as a vapor into the system. The system is made of a supportive media. The supportive media is made mainly from silica alumina, which is covered by silicon oil mainly, or of course polyethylene glycol. This supportive media is capable, of course, it is in a long tube to give enough time for the separation of the components. This retention time, which is present in this component, takes the time for it to be settled, according, of course, to the difference in the solubility between the components. After that, it goes to a recorder where it is being measured. As you can see, this is the injector port, and this is the flow meter where the carrier gas is being taken to be mixed with the mixture to be present to the supportive media. Now, after the components come out from the column, we have a detector. Before going to the recorder, we have a detector. Detectors are three types. First of all, one of them is called flame ionizing detector. As you can see from the picture, a flame is being introduced where it's supported by hydrogen and air, and the mixture is being exposed to this flame. This flame, first of all, is attached to two leads of a source of electricity to induce a current from these particles that are elevated from the flame. So whenever the mixture mainly of inorganic organic gases, passes through this flame, this ionized particles then being changed, increasing the current. So the change in the current gives a hint about the components present in the mixture, mainly of the inorganic, materials. But if we use what we call the thermal conductivity detector, we use it for inorganic gases as oxygen and nitrogen. It is made of, it's called also a catharometer. It's made of a heated element. This heated element, of course, has a resistance. So whenever the components pass by this heated resisting wire, its resistance changes by the presence of this components. This change is a hint about the type of the gas, and of course gives a hint about the amount. The bad thing about this chromatograph that we have to have a preliminary notice of the components of the mixture. We don't have to go through it knowing that there are components which we don't know. We know, have a hint about the presence. The third type of detector which detects the halogenated agents is called an electron capture detector. It's a device where produces electrons from a cathode, a heating cathode, to an anode. So we have electrons. So whenever the components of the mixture passes through this chamber, it's been ionized. This change in the the current flow will be detected, and it can give a hint about the type of the mixing gas present and its amount. So these are the three types of the detectors present in the gas chromatography. Clinical use, of course, measures volatile anesthetic agents, and it can give a hint about the concentration. Of course, it's used mainly in the laboratory because it is bulky. It measures, of course, barbiturate, phenocyanide, and so forth. Advantage of kit allows the identification of the measurement of very low concentration of drugs. The technique is versatile. That is advantage, as we said before, it cannot estimate continuous analysis, and you must have preliminary details about the components of the mixture. The mass spectrometry, this is the title of the chapter we are talking about. As you can see from the apparatus, the mass spectrometry also, it is versatile, and it's bulky, and it's used in laboratory mainly. So it is made of the sample, which, as we can see from the figure, is being present in a chamber, made of molecules. This molecules passes through a molecular leak. It is an opening where the molecules come, as we can see. These molecules are being bombarded by electrons. Electrons, of course, coming from a cathode, going to the anode, producing electrons. So they bombard the molecules. So the molecules are being ionized. This ionized components pass through a path. This path is being controlled by what we call a focusing and accelerating plates. As you can see, this turns in a speedy way to control the path of the agent I want to estimate by the detector. You see, so I'm controlling the passes of the different types through this focusing, and then it goes to a magnetic field. This magnetic field, of course, diverts this currents. Of course, the heaviest one will be settled downwards, and the lightest one regarding the mass will be in the upper part. So this focusing and accelerating plates controls the path of the component where I want to estimate, going to the detector, as you can see. So we have three passes. We only are keen about the path going to the detector, which is in the middle. So this is the method to measure the gases and the vapor of a mixture of components. The good thing about it, but it may be difficult for it to differentiate between two molecules where they have the same mass number as carbon dioxide and nitrous oxide. But the process of this procedures produces components of each of them. So, for instance, carbon dioxide, whenever it goes through, it decompensates to components as oxygen and carbon monoxide and carbon dioxide. So as we know, each of them has a special mass number. On the other hand, nitric oxide is being decomposed to nitric oxide, which has a mass number. So those degraded components are capable to differentiate between the two main gases, nitric oxide and carbon dioxide, whenever we have both of them present in the same path. So this is a good thing about it. The second thing, that it has a time of less than 100 milliseconds to work, and it can measure breath by breath, and you only need a very small sample to estimate the amount present. Other techniques, of course, we have, first of all, solubility of the anesthetic agent in oil, we utilize the crystal of quartz. Crystal of quartz, whenever they are electrified, they go through a resonance. They vibrate. This vibration has, of course, a frequency. So this crystal is being covered by an oil. So whenever the anesthetic is being subjected to this crystal where it is oscillating, it absorbs in the oil. This absorption is correlated to the type, of course, of the anesthetic, and it changes the frequency of the oscillation of the quartz according to the type of the anesthetic being absorbed. Of course, all this goes after Henry's law. The second thing is the infrared analyzer, as we said before, and the refractometer, where carbon dioxide was being examined. And we also use the velocity of ultrasound in different types of gases. This change on the velocity can they identify the type of the gas. So these are the other techniques of gas and vapor analysis. The less apparatus considering the further techniques of gas and vapor analysis is the Raman effect. Raman was an Indian chemist who won the Nobel Prize one day. It is based on that whenever electromagnetic waves are being subject to molecules, either they are being scattered, then the energy of radiation, the incidence of the energy of radiation equals the incidence of the radiation leaving. So this is one of the incidents that can happen. The second thing, that the molecule can absorb completely this radiation as carbon dioxide in the infrared analysis. The last thing is that there is a partial obstructions. That means that some of the molecules are, of the radiation are being scattered. Most of it is scattered. Only a very small amount is being absorbed, maybe 1 over 10 millions of the rays. So this is why we call it a weak response. So the apparatus simply is made, as we can see, from a high source of light made of halogen neon. As we said before, it was a weak response, so we ought to have a strong light source. And then we have ports, as we see, where the mixture is being introduced through this chamber. And then we have the detectors. The detectors are 8 in number, but in this figure only 2 are shown. The detector is made of a filter and of a photo detector. As we see, the scattered radiation, and some of the radiation is being absorbed by the molecules. And then after there be, and of course, each type of agent has its special frequency. As we know that the radiation has its own frequency. So each of the components, as you can see, has its own frequency to be absorbed. So whenever they're being absorbed by a special filter, they are being transmitted to an electrical signal going to a monitor. So this is what we call the photo detector, because it detects the amount of absorbed radiation and transfers it to electricity being displayed on a screen. So these are the 2 types of filters present in the figure. Only, of course, I told before that there are almost 8 of them. Of course, the light is being subject between 2 mirrors to make it strong, go on there and here. And at the same time, we ought to have something to dry off all the water present. And this heat of helium is capable to degrade the products. So these products by a pump must be displaced, otherwise it will affect the readings. And these are some nice things about the Raman. Raman can be used to diagnose the brain injuries or whatever, there is something in the brain, and it can use, as we said, testing breath to breath of respiration. And these are some points that I saw before that in Massachusetts Institute, they are trying to use it to locate the epidural space, and these are some questions. And of course, as we said, the versatile means having a great diversity of variety, has many varieties. This is a hint about the subject. I hope that I succeeded. Sorry for my mistakes, and I hope to see you later on.